Our topic is week 8 to 9. As you can see in our LMS, isang week lang ito nilagay yung 8 and 9, but then dalawang weeks yun, no? So we have to discuss the force due to magnetic fields and sources of magnetic fields. This is part 1 of 2. So meron tayong part 2 that will be next week. So we have the learning objectives. At the end of this presentation, you will be able to A1, describe the interaction between poles of magnets. 2, differentiate electric interactions from magnetic interactions. 3, draw the magnetic field pattern around a bar magnet and between two poles of two bar magnets. 4, define magnetic field and describe the magnetic field lines of various magnetic fields. And solve problems involving magnetic fields and magnetic forces due to magnetic fields. So let us define magnetism. Magnetism deals with the study of the source and nature of magnetism, the behavior of material with the presence of magnetic field and magnetic force. So this is a property of material due to unbalanced spin of electrons in an atom. If you recall the one topic of chemistry 1, about electron distribution, there is a topic of magnetic property of an element of an atom. We learn na in one orbital there are maximum of 2 electrons that can situate in an orbital, provided that the spin of the first is opposite to the spin of the second. Now, yung opposite spins would neutralize, no? There is neutralize yung spin kung dalawa, opposite, clockwise yung isa, counterclockwise yung isa. Pero there are cases na mga unpaired electrons, so hindi na neutralize. So isa yun sa reason for the magnetic property ng atom. So meron tayong mga tinatawag na paramagnetism, ferro, no? Recall lang tayo sa chemistry. Okay. So in most elements, yung electron spin opposed to one another. So kaya nag-neutralize. And magnetic forces cancel each other. But in magnetic substances, this spinning motion reinforces each other. Like na-discuss sa domain theory. Now, there are 2 branches of magnetism. First is magnetostatics. The second is magnetodynamics. Magnetostatics, we have the magnetic source is at rest. Magnetodynamics naman, the source of magnetism is in motion. And the brief history about magnetism. Magnetism came from the word Magnesia, the ancient name of Turkey. So it was observed by ancient people in Magnesia that a huge rock, what we call lodestone, this is a natural magnet found in ground containing iron ore or magnetite. It has an ability to attract metal. So those times, thousands of years ago, no, the Chinese built compasses for having or for use in navigation. It was shape of a spoon with rounded bottoms on which they balanced. No? That simple compass aligning in north and south directions. So what is a magnet? Simply, a magnet is any material that has an ability to attract metal. It can be permanent. So when say permanent, ito yung makikita natin na bar magnet, and the bended form ng bar magnet, yung horseshoe. And the other one is temporary, permanent or temporary. So yung temporary, the source, ito yung mga sa electric conductor, like electromagnet. So without a current, hindi siya maging magnet, no? So it could be from a ferromagnetic material, special sa permanent magnet that can be permanently magnetized, such as iron, cobalt, nickel, and many more. So it is explained through alignment of what is called magnetic domain. Magnets have two poles, the N and the S, or the North Pole and South Pole, and magnetic poles always occur in pairs of North and South. There is no such thing as North Pole only or South Pole only. Now, next is the uses of a magnet. It is used in compass needles, used to power speakers, in stereos and radios, in earphones and televisions. Horseshoe magnet, used in generators and motors. And in the medical field, magnet is important in scanning machines called MRIs. This is magnetic resonance imagers, which doctors use to look inside people's bodies. And also in the debit credit cards, the dark strip on the back of the card is of magnetic nature and are used to store data, just like computers or drives. So, few lang ito sa mga uses ng magnet. Next, a magnet has the greatest strength at the poles, little or no strength at the middle. Now in the figure, we have the arrows, no? So take note of the arrows that initially started from the north. Sorry. Okay, from the north, papunta ng south. And from south, balik sa north, forming a closed loop. So may mga portion sa field lines na close ang field. So kung saan closer yung field lines, yun ang greatest strength. Sa middle part, ito yung less or no strength. Depende sa strength ng magnet. So the ends are called poles, the N and S. And when we hang a bar magnet from an iron stand, the bar end pointing north is the North Pole. And most importantly, like poles repel and like poles attract. So like poles repel, this is force of repulsion and force of attraction. Force of attraction or repulsion depends on the strength of magnet and distance between the poles. How to make a magnet? No? So using a temporary magnet can be made when we stroke bar of magnetic material in one direction with a magnet. So done by realigning of domains. So aside from that, using electricity, or bring magnet nearby. How to demagnetize or how to decrease the magnetism of a magnet. No? One is by applying heat, second is by contact or simply passing a magnet in alternating direction, and by hammering. Earth is a huge magnet. No? Earth is made up of about 1/3 land, and this land is rich in ferromagnetic materials like iron. So the Earth's magnetic poles are into Earth's geographic or geographic poles. Earth is a large magnet. Now, when we bring this compass near or at the surface of the Earth, so si North would attract from the south pole of the Earth's magnet. Si South would attract sa north end ng Earth's magnet. So the north pole of a compass needle is a magnetic north pole. It is attracted to geographic north pole, which is magnetic south pole. So opposite magnetic poles attract. Next is magnetic field. Magnetic field is a region around a magnet. Saan yan dito? No? A region around a magnet in which magnetic effects are observed. Lines of force are closed arc or is closed arc from north to south pole. From north, so nakita nyo kanina na dito yung SN, no? Sa Earth. So, galing sa north, pa-out, balik sa south. Forming a closed loop, no? Again, initially, from north, back to south, back to N, no? Forming a closed loop. Similar to the bar magnet, nag-start sa north, papunta sa south, at south to north. Forming a closed loop. So, it never, or field lines never cross, and most concentrated at poles. So again, as strong ang magnetic field when the field lines are closer with each other. Weak pag sobrang layo yung isang line to the other lines. So from the given diagram, at which point mark on diagram is the magnetic field strongest? So simply sa left and right figures, it's A. Points A, no? And then what about weakest field sa B, no? Lesser ang magnetic field at point B. Now if we cut a magnet into half, pagputulin natin itong magnet, no? Bar magnet. The first, in the first half, yung N, merong S, no? Yung kaputol, mahimong N. Naging NS. NS, NS, no? Pagputulin pa further, NS, NS pa rin yun, no? So magnetic fields, this is a vector field in the neighborhood of a magnet. When we say vector field, we need to consider direction, not only magnitude, no? And then electric current, when we say electric current, produced yan by moving charges, and even changing electric field in which magnetic forces are observable. Magnetic field transmit magnetic forces and represented by field lines. The unit of magnetic field is Tesla, or its equivalent old unit niya is volts. Now, let us see the differences and similarities of electric fields and magnetic fields. Electric field produced by two kinds of charges, the positive and negative. While magnetic fields are associated with two magnetic poles, the north and south, although they are also produced by charges, but moving charges. Electric field, like charges repel and like charges attract. Magnetic field, like poles repel, unlike poles attract. In electric field, it points in the direction of the force experienced by a positive charge. In magnetic field, it points in the direction of the force experienced by a north pole. Electric field, positive and negative charges can exist separately. So, pwede si positive lang, pwede si negative lang. But in magnetic field, it should be in pair. So, naka-NS talaga yun. So, always come together. In electric field, may definite starting and ending point or end point. So, started from positive, would end sa negative. Sa magnet naman, start from north, papunta sa south, from south, balik sa north. Continuous loop. Okay. So, for a moving charge, when we compare a static or at rest charge, no? At charge at rest, no? A static electric charge does not feel a magnetic field. No magnetic force is exerted on it. If an electric charge is moving, it generates its own magnetic field, which interacts with the original magnetic field. So the magnetic field exerts a force on a moving electric charge. So in the figure, we have the magnetic field produced by NS or large, say, magnet, no? And then we have a moving Q in the vicinity of the field, no? So the upward magnetic force F on a charge moving in a B field. We have a force F and B is magnetic field. Now this shows directions of force, velocity, and B field. To compute for the force experienced by this Q or charge moving in the vicinity of magnetic field, and we have to use this formula. QVB, sine of the angle, where the angle is the angle between the velocity and magnetic field. Okay, so we have the Danish physicist Hans Christian Ørsted. My experiment ito about electric current. Now in the diagram, when the switch is open, there is no deflection of the compass needle. Kailangan ito ng battery source, no? When the switch is closed, allowing charge to move, there is electric current, no? So there is deflection ng compass needle. That shows that there is magnetic field in the current carrying conductor. So by closing the circuit or the switch, electrons move through the wire, creating an electrical current. So the movement of the electrons through the metal of the wire produces a magnetic field around the wire. The compass needle reacts to that magnetic field. That's why there is deflection. So an electric current will produce a magnetic field which can be visualized as a series of circular field lines around a wire segment, like in the figure. Now, yung direction naman ng magnetic field is simply by using the right hand rule. So wherein the thumb is in direction of current and the curl of the fingers is the direction of the magnetic field. So marami yan, no? Now, yung strength ng magnetic field depends on the distance from the wire. Of course, the nearer the circle, the higher is the B, no? The far, kung i-consider natin yung distance from the conductor doon sa last circle, mas lesser ang B. sa last circle. So magnetic field depends on distance. So to find for the combined force of electric field and magnetic field, we have this Lorentz force law. No? And in the formula, we have this F is equal to QE. So Q times E is the force experienced by the charge when in the presence of the electric field. Ito yung force experienced by the charge moving in the presence of magnetic field. So total lang sa dalawa. Okay. What about the moving charge? So recall that the magnetic field on a charge particle is orthogonal to the magnetic field such that F is equal to QVB sine of an angle. Orthogonal meaning naka 90 degrees. So angle is the angle between magnetic field and the particle's velocity. The direction is by the use of a right hand rule, but this time hindi na niyo i-curl yung hand niyo, kundi i-open na niyo yung palm niyo, no? Yung thumb pa rin yung direction ng V, yung sa middle finger is the direction of magnetic field. If magnetic field is not 90 degrees, in this case, in our diagram, naka 90 degrees si B from V. But if the B is at certain angle, halimbawa, this is 40 degrees, we want the B component perpendicular to velocity. So ito ang kunin natin. This is B perpendicular or B sine of 40. So using right hand rule, F is perpendicular to the VB plane. So if this is our VB plane, kung ito ang VB plane, ito 90 degrees ang F from P and 90 degrees ang F from V. In the topic of magnetic field, it's very important that you are imaginative, no? Because we are dealing with 3D. If the magnetic field and the velocity are parallel, when we say parallel, if the direction of velocity is upward and the direction of magnetic field is also upward, then the angle between V and B is 0. The sign of 0 is 0. Therefore, that would make the force equal to 0. Pag anti-parallel naman, if this is the direction of velocity, tapos downward yung magnetic field, the angle between velocity and B is 180 degrees. So sign of 180 degrees is also 0. That is why, again, if the magnetic field and velocity are parallel or anti-parallel, then sine of theta equals 0. Therefore, force is 0. It has no direction. For example, a 2 nanocoulomb charge is projected with a velocity of 5 times 10 to the power 4 m/s. This is our velocity and angle with 3 millitesla magnetic field. What are the magnitude and direction of the resulting force? So what you have to do is to collect anong quantities given. Summarize niyo yan dito. Nano meaning 10 to negative 9. And we have magnetic field 3 millitesla. So milli meaning 10 to negative 3. Given yung angle. So i-recall niyo yung formula and then plug in yung lahat ng given and then do the calculations. So the force in this example is 1.50 to the power of negative 7 newtons. And this direction is upward. No? So, but then it depends on the orientation of your hand. No? Basta F is always perpendicular to the VB plane. Next is the magnetic force on a conductor. How to compute for the force when a conductor is in the field, no? In the magnetic field. Now, the magnetic field exerts a force on a current carrying wire with a direction given by the right-hand rule. Now, familiarize natin ito. This blue cylindrical is the conductor. The arrow in the cylinder is the current I. Itong arrow red is the length of the conductor and 90 degrees, naka 90 degrees sa conductor ang force. Now, what is this X? So, X indicates direction of magnetic field. Okay. So, pag makita ninyo merong X, ibig sabihin nito, ang magnetic field from me to the monitor. So, X indicates tail of an arrow. Na kung makita naman ninyo merong dot sa center, circle, merong dot sa gitna, ang ibig sabihin yan, yung direction ng magnetic field is from the monitor toward you. Or from the monitor papunta sa akin. From the monitor papunta sa inyo. So, ibig sabihin that is the arrowhead. Na? Okay. So, to compute for that magnetic force, we have F is equal to ILB sine of V. So, where F is force, I is current, L is the length of the conductor, and B is the magnetic field. And the angle is between I and B field. So, F is always perpendicular. Again, F is always 90 degrees to the conductor and the field, and the magnetic field. Let's have this example. A straight horizontal wire carries a current of 50 amperes from west to east in a region between the poles of a large electromagnet, where there is horizontal magnetic field toward the northeast, with magnitude 1.20 Tesla. So find the magnitude and direction of the force on a 1 meter section of wire. Now, magnetic field is a vector quantity. So it is very important to consider always the direction of that field. So, ang straight horizontal wire situated from west. So, drawing niyo dito. Conductor. And yung direction ng current is from west to east. It's our I. Okay. So, equal to 50A. So, nakasulat yan dito. Next is that our magnetic field is to northeast. Ano ibig sabihin ng northeast? By the way, when we recall the direction, no, how to express or how to determine direction, i-recall natin yung sa, depende yun, no, anong gagamitin. Pwede Y, X, and to the monitor is the negative Z, out from the monitor is the positive Z. Or pwede na I, J, K. At saka pwede rin itong angle. No? Pwede rin angle gamitin natin dito sa direction. And saka pwede itong NSWE, North, South, West, East, no? Okay. So, since nakalagay dito that the direction of magnetic field is northeast, then we need to express northeast in angle. Kasi northeast is 90 degrees. So, north from east is 90 or east from north is 90. Northeast is in between, sa gitna. So, kung 90 ang total ng N to E, then what is half of 90? That would be 45. Okay, very good. Half, 45, no? So, that's why we have here 45. And next thing, so ano ibig sabihin ng 45? So, lahat ng field lines or magnetic field naka-direct from to northeast. Marami yan, no? Pero isang presentation lang para hindi tayo malito, no? So, ito yung mga direction. Yan ang direction ng B. So, next thing is to recall the formula and then plug in the given quantities. Then use your calculator and find the magnitude of the force. So, F therefore is 42.4 newtons. And this direction is perpendicular to the IB field. So, if the IB field, kung ang I is in this direction and B in that direction, so saan ang direction ng force? It is perpendicular to I and B. No? Okay. To compute for the magnetic flux, so kung nandoon kayo sa week 1, hindi na kayo manibago sa topic na magnetic field and magnetic flux. So sa week 1 or week 1, no? So there is a topic about electric field lines and electric flux, no? So magnetic field lines are imaginary lines in a region where magnetic force is present. And magnetic flux is the total number of field lines entering in a given area. So sa electric field, we have field lines, no? How many field lines crossing in a virtual surface? Ito yung virtual surface. And in magnetic flux, how many magnetic field lines crossing our virtual surface? So to compute that, we have magnetic flux is equal to V times A or equal to B cosine of an angle times A. So magnetic field is sometimes called flux density. Now, my question dito, why is it that the magnetic flux on a closed surface is 0? So the answer, the magnetic flux in a closed surface is 0 because the magnetic field lines are continuous loops. All closed surfaces have as many magnetic field lines going in as coming out. Hence, the net magnetic flux through a closed surface therefore is 0. Okay, so sample computation about magnetic flux. A magnet with magnitude 0.004 Tesla is placed on a square of side 3.0 cm. If the square was oriented 20 degrees relative to the magnetic field, what is the magnitude of magnetic flux in the square? So, recall natin yung given. This is magnetic field. We're 0.004 T is magnetic field. 30 cm is side only, one side of a square. And the angle is 20 relative to the magnetic field. So what is the magnetic flux? So yan ang question mark. Okay, simply from the side ang given, from this side, pwede tayo makakompute for area. Since square ito, then area is equal to side times side. Like in a rectangle, length times width. No? So this is side times side or side square. Then, from the side na 3.0 cm, convert that to m by dividing 100. That's why we have 0.03 m. And square of that is our area. For 9 times 10 to the power of negative 4 square meter. Now, since meron tayong area, B at angle, then let us substitute that to the formula. And then, do the calculation. I hope makuha ninyo yung magnetic flux equal to 3.38 to the power of negative 6 Weber. Next is to analyze the motion of a charged particles moving in a magnetic field. So again, in our diagram, kita natin na meron tayong X, meaning tail ito ng magnetic field. So the direction of magnetic field is from me to the monitor or from you to the monitor. Now, in analyzing motion of a charged particles moving in a circular motion in the presence of a magnetic field or in the presence of the magnetic field, then we need to recall the centripetal force formula in your General Physics 1, where you analyze the motion of a particle moving constantly in a circle. That's why centripetal force. And you also recall the force of a charge moving in the presence of magnetic field. So that when we equate the two as a parehong force naman ito, then we have mv squared over r, where r is the radius of the circle, and is equal to qvb. We can cancel one v sa left side with a v sa second side, no? That's why we have mv over r is 2 qb. So if you want to find the b, magnetic field, then we have mv over qr. Or if you want to find r, then r is mv over qb. Okay, so the force is maximum when the charge moves perpendicularly to the magnetic field lines. Halimbawa, ito na yung situation, tapos andyan yung circle, no? Yung charge would move in circular motion with the presence of magnetic field, no? In a region wherein there is magnetic field. So kung ang direction is from me to the monitor, this circle is perpendicular to the magnetic field. So in this case, force is maximum. But then, when the circle is parallel to the magnetic field, the force is 0. Okay, so one example to illustrate that. A problem states that an electron at point A, this is our point A, and point B, has a speed of, so automatically this is our V. So find the magnitude of the magnetic field. That will cause the electron to follow the semicircular path from A to B. So ito yung semicircular path ng electron from point A to point B. So notice na we are given diameter kasi half ng circle ito. So diameter agad yan. So kalahati ng diameter is radius. So radius therefore is 0.05. And we need to convert that 0.05 to m. Kasi naka-cm yun, no? So divided by 100. That's why we have 0.05. And our velocity is 6 to the power of 6. Now, saan galing ang ilalagay dito sa m and q? Now, in week 1, I gave you the constants for electron and proton and neutrons yata yun, no? So, constant na electron, mass, charge, yun ang commonly na magagamit. So, by the word electron, kasabay na itong mga constant dito. So, the mass of electron is 9.1 to negative 31 kilogram, and its charge is 1.6 times 10 to negative 19. So, this is not minus 19, no? So, once na ma-substitute niyo yan, then do the calculation. No? So, the magnetic field in the problem is 6.8 to negative 4 Tesla. And this direction is into the plane of the figure. Okay. So, for our lesson summary, magnetism is one aspect of combined electromagnetic force, refers to physical phenomena arising from the force caused by magnets, objects that produce fields that attract or repel other objects. And magnet is any material that has an ability to attract metal, could be a permanent magnet or a temporary magnet. To make a magnet, temporary magnet can be made when we stroke a bar of magnetic material in one direction with a magnet. Aside from that, using electricity. How to demagnetize? Apply heat or passing a magnet in alternating direction in contact, no? And third, by hammering. Take note of the following. A magnet has greatest strength at the poles, less, little, no strength at the middle. Hence are called NS poles. And like poles repel and like poles attract. Force of attraction or repulsion depends on the strength of magnets and distance between poles. Okay, so let us continue. Magnetic field is a vector field in the neighborhood of a magnet. An electric current or changing electric field in which magnetic forces are observable. And magnetic field is represented by field lines that start at the magnet's north pole and end at the south pole. The unit of magnetic field is Tesla. Okay, to solve for the force, to find for the force of a moving charge, moving in the magnetic field, then use the formula. F is equal to QVB or QVB sine of angle. The direction is simply to follow the right-hand rule. In this example, or in this part, simply you open your palm. So the thumb is the direction of velocity, the middle finger is for the direction of magnetic field. So to compute for the magnetic flux, where magnetic flux is the total number of field lines entering in a given virtual area, flux is B times A, or magnetic field times area, or B times A cosine of the angle. To compute for magnetic force on a conductor in the presence of magnetic field, BIF is equal to ILB, sign of angle, where the angle is, ito yung angle between I and B, or current and magnetic field. So the force is always perpendicular to the conductor and the field. In considering a motion of a charged particles in a magnetic field, then we have the formula R is equal to mv over qb. R is equal to mv over qb, or if you want to find B is simply mv over qr. So that's all for today. I would like to say thank you so much